cm thick corner wall using English bond, bench and channel for the inspection chamber and the manhole, fix a cover with a channel and provide slope, make holes using a portable hand-operated drilling machine, cut a brick wall using flat and pointed cold chisels, make holes for plumbing fixtures and fill and plaster holes and chases. First, we are going to learn to bench and channel the base plate. For this, the required materials and tools are spade 1, spirit level 1, hammer 1, chisel 1, mortar pan 1, mason trowel 1, bricks as required, sand 5 boxes, water as required, cement as required, aggregate as required, rungs or footsteps as required. Let us now lay a 23 cm thick corner wall using English bond. Mark a line with chalk to set out the position of the job. Accurately mark the overall dimensions of the model job using dry bricks and ensure that the wall thickness aligns with the length of one brick. Lay the first stretcher of the first course at one end of the front elevation of the model job and lay the queen closer next to the corner brick of the first course. Check width of the first course of the front and rear of the brickwork. Lay the second stretcher at the opposite end of the front elevation of the job and check the level from the first stretcher. Lay the bed for a rear elevation of the first course of stretchers. Draw the trowel point along the front elevation stretchers to form an additional furrow. Check for the alignment level and width. Build up one end of the job with a header closer and on the second course. Check for gauge, level, plumb and ranging in width as the work proceeds and repeat at the other end of the job using lines and pins. As the next stretcher course is laid, make sure that the mortar bed is furrowed clear of the gaps between the bricks already laid on the course. As the headers are laid, ensure they are level across the width of the wall. This job requires accurate setting out and squaring of the ends on the first course. Check the stepped end of the wall. The closers must be cut to the correct size. The headers and the back course of stretchers must be level across the width of the wall. The headers must be centrally positioned over the across joints or stretchers below. The cross joints should be of uniform width. Use full bricks except for the closers. After finishing, check the isometric view of the corner wall. Let us now learn to lay out and build one brick or a 23 cm wall using a Flemish bond. By the end of this exercise, you should be able to lay bricks with alternate headers and stretchers and lay the queen closer. Lay bricks with alternate headers and stretchers. Assemble the bricks in the brick area. Mix the mortar and load the mortar pan. Snap a chalk line longer than the required length. Mark a line for a 90-degree angle at one end of the straight line already marked. Lay out the corner with a stretcher. Lay one header and one stretcher alternating each course. Provide an overlap of 1/4 brick to avoid continuous vertical joints. Provide uniform bed joints and vertical joints. Lay the queen closer. Plumb and level after laying the first course and check the alignment. Lay the queen close to the queen header to avoid vertical joints. Attach the line by pushing a nail to which the line is attached under the end of the brick on the left end of the wall. Pull the line up over the top of the brick and push the line to face the bricks. Set the line 2 mm out from the edge of the brick and the top surface with the top of the brick. Fill the space between the leads using a line as guide after fixing a line. Resume building to the specified height and fill the wall to the line. Correct bonding arrangement with proper bond has to be followed. Check the work for correct height. Check the square, level, plumb and alignment for straightness. Brush the work after completion and pointing. The inspection chamber. Mix cement concrete with brick bats, cement, sand and water. Mix cement concrete with cement, sand, aggregate and water. Place the cement mortar with the aggregate to the base inside the inspection chamber. Channel and bench using forming tools. Provide covers with channels and make a 45-degree slope benching using brick bat cement mortar at the top. Manholes. Mix cement concrete with aggregate. Place the cement concrete at the inside base of the manhole. Bench and channel using forming tools. Provide a rung for deep manholes. There are 3 kinds of CI covers for the manholes. Cover the top of the manholes with a channel. Provide slopes to prevent rainwater from entering. Let us now learn to cut a masonry wall for concealing using electric cutting tools. By the end of this task, you will be able to make holes using a portable hand-operated drilling machine. Cut the brick wall using a cold chisel that is flat and pointed and make holes for plumbing fixtures and fill and plaster holes and chases. For this, the required tools and materials are portable hand-operated drilling machine 1, portable chase machine 1, wooden float 1, mortar pan 1, mason trowel 1, hammer ball peen 1, cold chisel flat and pointed 1, spirit level 1, roll jumper 1, straight edge 1, wall jumper 1, plump bob 1, cement as required, sand as required, aggregate as required, water as required, pipes as required, clamps as required, screws as required, plug wood as required, and MS rod as required. Now, let us look at cutting a brick wall and fitting pipes. Cut the chase in the brick wall using a chasing machine. Cut the box hole in the brick wall using a flat and pointed cold chisel. Make a through hole using a wall jumper. Make holes for wall-tight plugs to fix clamps. Make a through hole using a portable hand-operated drilling machine. Fill the chases with rich cement mortar. Fill the holes with cement mortar. Plaster the portions with cement mortar. Level using a straight edge and a wooden float. Check the level using a spirit level and a plump bob. In this video, we have discussed how to lay a 23 cm thick corner wall using English bond, bench and channel for the inspection chamber and the manhole, fix a cover with a channel and providing slope, make holes using a portable hand-operated drilling machine, cut a brick wall using flat and pointed cold chisels, and make holes for plumbing fixtures. Hope you have a clear understanding of this session. Thank you all and see you again in the next video. Hello everyone and welcome to this module on the plumbing trade. In today's video, we are going to demonstrate an inspection chamber, a manhole and a gully trap. By the end of this lesson, you will be able to demonstrate an inspection chamber, demonstrate a manhole and demonstrate a gully trap. For this, the required materials and tools are measuring tape 1, spade 1, pickaxe 1, mortar pan 1, trowel 1, spirit level 1, plumb bob 1, straight edge 1, tube level 1, crowbar 1, cement as required, brick as required, brick bats as required, aggregate as required, river fine sand as required, CI frame with cover as required, lime powder as required. Let us lay out and build a half brick thick corner wall or stretcher for the inspection chamber. Assemble the material in the work area. Set the mortar pan approximately 1 meter from the wall to provide sufficient working space. Lay out the L corner on the floor using the steel square and pencil or chalk. Extend the line little longer than the actual corner measures using chalk. Lay out the first course of dry bond keeping the head joint uniform about 10 mm using the forefinger. Remove the corner brick or brick number 1. Spread the mortar and relay without moving the bricks in between. Remove the end brick or brick number 2 and spread the mortar. Level and plumb brick number 1 and brick number 2 and straighten the edge with a plumb rule. Lay brick number 3 using a level plumb and straighten the edge with brick number 1. Remove excess mortar from each course. All the joints should be of uniform thickness. Check the corner for squareness after laying the first course of brick. Check the second course for level. Take sufficient mortar and spread it to form a bed and lay 3 or 4 bricks. Spread the mortar along the bed using a trowel. Lay the mortar in the center of the bed area. Continue this method till the work is complete. Remove the excess cement mortar from the external and internal surface of the wall. Lay the corner brick. Use the trowel to tap it in place. Reading of the drawing according to the work spot. Excavate for the inspection chamber as per the drawing dimension and level. Lay the concrete as per the drawing. Construct brickwork with 75 bricks in the cement mortar ratio of 1:4. Smoothen the internal wall. Join the pipe with the brickwork to ensure there is no leak. Block the pipe to prevent entry of any foreign material. Plaster the inside walls with a 12 mm thick cement plaster, cement to coarse sand ratio of 1:3. Provide channel and benching with cement concrete 1:2:4 aggregate 20 mm normal size. Smoothen with cement. The depth of the channel and benching should be as per the drawing. Provide centering for the top cover. Fabricate and fix the reinforcement for the cover. Fix cast iron over the frame. Fix the top cover, cure the work and remove centering. Our next task is to construct a gully chamber. By the end of this exercise, you will be able to draw, read and mark the area, excavate and lay concrete cement, install the gully trap and wall providing, plaster the wall and fix the CI light duty cover. Excavate for the gully trap as per the dimensions and levels. Lay the concrete as per the drawing. Check the quality of the gully trap. Place the gully trap in level. Connect the gully outlet to the branch drain and test the gully and branch drain. Construct a 1.15 mm thick brick masonry chamber 300 × 300 mm inside a round gully trap from the top of the bed concrete up to the ground level. Fill the gap between the chamber walls and trap with cement concrete. Plaster the upper portion of the chamber above the top level of the trap with a cement mortar ratio of 1:3. Finish the plaster area with a floating coat of neat cement. Round off the corners and bottom of the chamber so as to slope towards the grating. Fix CI grading 300 into 300 on top of the brick masonry with a cement concrete ratio of 1:2:4. Smoothen the concrete. The finished top level of the cover will be about 4 centimeters below the ground level. Check the gully and branch grain for pass through the outlet to entrap the silt from the gully trap. Periodically, the gully trap has to be cleaned. Construction of a manhole. By the end of this exercise, you will be able to read the drawing according to the work spot, excavate and lay cement concrete, construct a wall, provide benching and channeling, fix the footrest and plaster the wall and provide a CI cover. Let us now learn to construct a manhole. Excavate for the manhole as per the drawing. Read the drawing carefully to prepare the required materials. Lay the concrete as per the drawing. Prepare a cement concrete for the base in the proper chamber ratio of 1:5:10. Construct brickwork with cement mortar ratio of 1:4. Ensure that the internal wall is smooth. Ensure that the external joints are smooth. Ensure that the place joint and brickwork are leak-proof. Block the pipe to prevent entry to foreign material. Plaster the inside walls with a 12 mm thick cement plaster where cement to coarse ratio is 1:3. Provide channeling and benching with cement concrete ratio of 1:2:4 with 1 cement, 2 coarse sand and 4 stone with an aggregate of 20 mm. Use neat cement to ensure smoothness. The depth of the channel should be as per the drawing. Provide proper benching in the chamber. Embed the MS footrests in cement concrete block of 20 by 20 by 10 cm using cement concrete in the ratio of 1:3:6. Fix the footrest 40 cm apart, projecting 10 cm beyond the surface of the wall. This is in the case of a deep chamber. Paint the footrest with coal tar. Provide centering for the top cover. Fabricate and fix the reinforcement for the cover. Fix cast iron over the frame. Concrete the top cover. Cure the work. Remove centering and remove the block. Fix the manhole cover and seal the manhole cover with grease. In this video, we have discussed how to demonstrate an inspection chamber, demonstrate a manhole and demonstrate a gully trap. Hope you have a clear understanding of this session. Thank you all and see you again in the next video. Hello everyone and welcome to this module on the plumbing trade. In today's video, we are going to construct a septic tank and a soak pit. By the end of this lesson, you will be able to construct a septic tank and construct a soak pit. For this, the required materials and tools are measuring tape 1, spade 1, pickaxe 1, mortar pan 1, trowel 1, spirit level 1, plump bob 1, straight edge 1, tube level 1, crowbar 1, cement as required, brick as required, brick bats as required, aggregate as required, river fine sand as required, CI frame with cover as required, and lime powder as required. Set out the septic tank. By the end of this exercise, you will be able to set out the septic tank, lay the cement concrete for its foundation, construct brick courses with bonding while providing the air vent. Let us now start the procedure. Mark line AB and point Q on the line AB. From the point Q, draw a line CD. Mark QM, that is equal to 2.10 meters. Mark JK equal to 5.10 meters. Mark a perpendicular line GH that is parallel to CD. Joining JKLM gives us the required septic tank. Excavate the rectangular septic tank to a depth of 2.75 meters. Lay the cement concrete. Place the base concrete of 1:2:4 ratio to a thickness of 25 centimeters. Level the top surface of the concrete bed with a slope of 1:10. Lay the brick courses with bonding. Lay the bricks around the wall using English bond, 1 brick thick using cement mortar ratio of 1:4. Lay a 40 mm thick RCC baffle wall 90 cm from the inlet end. Keep the inlet stoneware pipe 100 mm above the water level. Keep the outlet pipe 100 mm below the sewage level. Fill all the joints inside the septic tank. Fix an 80 mm CI vent pipe. Keep the vent pipe 200 cm above the ground level. Fix the CI cowl at the top of the vent pipe. Lay a 10 cm thick RCC in the ratio of 1:2:4 slab or removable slab over the septic tank. Our next task is to construct a soak pit. By the end of this exercise, you will be able to do a circular marking according to the size excavate a trench, construct a brick wall with a dry joint, Kneel with brick bats. Install an inlet bend and provide an airtight cover. Construction of a soak pit. Excavate a 1 meter circular pit with a depth of 2 meters. Construct the wall using broken bricks or broken rock. Fill the trench with brick bat or rock bat. Fix an inlet using stoneware and PVC with a 10 cm gap from the bottom. Do sand casing providing up to 30 cm on the sides. Construct a soak pit up to 45 cm in height from the ground level. Provide an RCC airtight cover to prevent rainwater from going in. In this video, we have discussed how to construct a septic tank and how to construct a soak pit. Hope you have a clear understanding of this session. Thank you all and see you again in the next video. Hello everyone and welcome to this module on the plumbing trade. In today's video, we will cover safety standards, protocols and first aid and understand the precautions that can be taken in the event of occupational hazards. At the end of this lesson, you will be able to administer first aid, perform rescue breathing and treat bleeding. Select a suitable fire extinguisher and use it to extinguish a fire and identify personal protective devices. It is important to learn basic first aid methods like rescue breathing and stopping bleeding in case of an injury. In order to administer artificial respiration, loosen the person's clothing so that it does not interfere with their breathing. Remove any foreign material from the person's mouth and hold the mouth open. Lay the person flat on level ground. Start artificial respiration without much delay. Refrain from sudden movements to prevent further injury and send word for a doctor immediately. Let us first resuscitate the person by using the Nelson's arm or lift back pressure method. Place the victim face down with arms folded and their head resting on their palms. Kneel near their hand with your hands on their back, beyond their armpits. Fingers spread downward and thumbs touching. Rock forward, keeping your arms straight, pressing the victim's back to expel air from their lungs. Synchronize backwards with your hands sliding along the victim's arms, grasping their upper arm just above the elbows. Continue to rock backwards. Rock back, gently raise the victim's arms towards you until you feel tension in their shoulders. Then, lower their arms and return hands to the initial position. Continue artificial respiration till the victim begins to breathe naturally. In some cases, it may take a long time. When the victim revives, keep them warm with a blanket, hot water bottles, or warm bricks. Stimulate circulation by stroking the insides of their arms and legs towards their heart. Keep the victim lying down and avoid exertion. Avoid the Nelson's arm lift back pressure method if there are chest or belly injuries. Do not give stimulants until they are fully conscious. Let us learn to resuscitate the victim by using the Schaefer's method. Position the victim on their belly, one arm extended forward, other arm bent at the elbow, face turned sideways and resting on their hand or forearm. Kneel astride the victim, their thighs between your knees, your fingers and thumbs positioned as shown. With arms held straight, swing forward slowly, gradually applying your body weight onto the victim's lower ribs to expel air from their lungs. Now, swing backward, immediately relieving pressure from the victim's body, allowing their lungs to fill with air. After 2 seconds, swing forward again and repeat the cycle 12 to 15 times per minute. Continue artificial respiration until the victim begins to breathe naturally. Do not use this method in case of injuries to the victim on the chest or belly. Let us resuscitate the victim by mouth-to-mouth method. Lay the victim flat on their back. Then place a roll of clothing under their shoulders to tilt their head back, chin pointing straight upward. Grasp the victim's jaw, raise it until the lower teeth are higher than the upper teeth, or place your fingers near their earlobes and pull upward. Maintain the jaw position to prevent the tongue from blocking the air passage during artificial respiration. Take a deep breath and place your mouth over the victim's mouth, making airtight contact. Pinch the victim's nose shut with the thumb and forefinger. If preferred, use a porous cloth between mouths. For an infant, cover the mouth and nose with yours. Blow into the victim's mouth until the chest rises. Remove your mouth and release your hold on the nose, allowing them to exhale. Listen for rushing air. The first 8 to 10 breaths should be rapid, then slowed to about 12 times per minute and 20 for an infant. If unable to blow air in, check the victim's head and jaw position and mouth for obstructions. Retry forcefully. If the chest still doesn't rise, turn the victim face down, strike back sharply to dislodge any obstructions. If the air enters the stomach, gently press during exhalation to expel the air. Let us resuscitate the victim by mouth-to-nose method. Use this method when the victim's mouth will not open or has a blockage that cannot be cleared. Use one hand to keep the victim's lips shut. Seal your lips around the victim's nostrils and breathe into them. Check if the victim's chest rises and falls. Repeat this exercise 10 to 15 times per minute till the victim responds. Continue this until the doctor arrives. Let us learn to resuscitate a victim who is under cardiac arrest using CPR or cardiopulmonary resuscitation. In cases of cardiac arrest where the heart has stopped beating, immediate action is crucial. Quickly check if the victim is under cardiac arrest. This can be ascertained by the absence of a pulse in the neck, blue color around the lips, and a widely dilated pupil. Lay the victim on their back on a firm surface and kneel alongside facing the chest and locate the lower part of the breastbone. Place the palm of one hand on the center of the lower breastbone, keeping fingers off ribs. Cover the palm with the other hand and lock your fingers together. Keeping your arm straight, press down on the lower part of the breastbone, then release the pressure. Repeat this step 15 times, at least once per second. Check for cardiac pulse. Move back to the victim's mouth to give 2 breaths of mouth-to-mouth resuscitation. Continue with another 15 compressions of the heart, followed by 2 breaths of mouth-to-mouth resuscitation, and check the pulse at frequent intervals. As soon as the heartbeat returns, stop the compressions immediately, but continue with mouth-to-mouth resuscitation until natural breathing is fully restored. Place the victim in the recovery position, ensuring that they are kept warm, and then get medical help quickly. Let us learn to treat a bleeding victim. Determine the location of the bleeding. Elevate the injured area above the heart if possible. Apply direct pressure to the bleeding area using a sterile cloth. Keep the pressure on for 5 seconds. Check to see if the bleeding has stopped. Continue to apply pressure for another 15 minutes. Clean the wound and bandage it with a pad. Advise the victim to seek medical attention. In this section, we will learn to use fire extinguishers. Alert people surrounding you by shouting "Fire, fire" when you notice fire. Inform the fire service or arrange to inform immediately. Open the emergency exit and ask everyone to move away. Put off the electrical power supply. Analyze and identify the type of fire. Select a CO2 or carbon dioxide fire extinguisher. Then locate and pick up the CO2 fire extinguisher. Check for its expiry date. Break the seal. Pull the safety pin from the handle. The pin is usually located at the top of the fire extinguisher. Squeeze the handle lever slowly to discharge the agent. Sweep from side to side approximately 15 centimeters over the fuel fire until the fire is put off. Remember PASS. This will help to use the fire extinguisher. P for pull the pin. A for aim at the base of the fire. S for squeeze the lever. And S for sweep from side to side. Let us identify the required personal protective equipment used for protecting the different parts of the body. Safety shoes to protect the feet. Safety clothing to protect the body. Safety helmet to protect the head. Safety gloves to protect the hands. Safety mask to protect the lungs. Safety glasses to protect the eyes. Safety earmuffs to protect hearing. Safety harness to protect against any fall, and a safety vest to improve visibility. In this lesson, we have learned to administer first aid, perform rescue breathing, and treat bleeding. Select a suitable fire extinguisher and use it to extinguish a fire and identify personal protective devices. Hope you have a clear understanding of this session. Thank you all and see you in the next video. Hello everyone and welcome to this module on the plumbing trade. In the previous session, we learned to administer first aid and use a fire extinguisher. By the end of this lesson, you will be able to identify occupational hazards and their potential sources and suggest suitable methods to avoid them, identify and segregate the waste material in the workshop, take preventive measures to avoid electrical accidents, understand and practice precautions to be followed while working in the trade, and record the safety points while using trade tools and equipment. Let us now take a look at the various occupational hazards and their sources. Deafness can be caused by noise or explosives. Injury can be caused by explosives, non-control devices, no earthing, or poor housekeeping. Sickness can happen due to virus or smoking. Moving forward, let us identify and understand safety signs that fall into one of the four categories: prohibition, warning, mandatory, and emergency. Prohibition signs are red in color and used to prevent certain activities in certain situations. Here are some examples: no smoking, avoid inflammable objects, do not extinguish with water, do not enter. Warning signs are yellow in color and indicate a potential hazard. For example, danger or toxic, high voltage, general warning, and flammable material. Mandatory signs are blue in color and indicate what one must do in order to remain safe. For example, wear safety gloves, wear safety goggles, wear a safety helmet, and wear earmuffs. Emergency signs are green in color and used to indicate the nearest location of or directions to emergency related facilities. A few examples are first aid, direction to the emergency exit, emergency telephone, and drinking water. Now, we will learn to identify and segregate waste material from the workshop. Segregate the cotton waste material and store it in a separate bin. Collect the chips using a hand shovel and a brush. Do not handle the chips by bare hands. Since there may be different metal chips, separate them according to the metal and store them in separate bins. Clean the floor in case of an oil spill. Let us now focus on identifying and then suggesting suitable solutions to avoid occupational hazards. Always wear suitable protective footwear while working on the shop floor. Always ensure that the plumbing file has a handle. Always ensure that the ball peen hammer has a wedge attached to it. Ensure that you do not carry an open tool in your pocket. Avoid a mushroom head chisel while chipping metal surfaces in order to avoid shattering. Always wear safety goggles while chipping metal surfaces to avoid accidents. Lifting slings must be inspected before every use. When moving a load, ensure to plan the route, clear pathways, and maintain clear communication. Clear the area and maintain a clear line of sight while lifting a load. Ensure that the area below and around a suspended load is clear of people, equipment, and obstacles. Now, let us focus on taking preventive measures to avoid electrical accidents and learn how to rescue a person from a live wire. Disconnecting a person from a live supply. Observe the person receiving an electric shock. Interpret the situation quickly. Remove the victim safely from the live equipment by disconnecting the supply or using one of the items of insulating material. Move the victim physically to a nearby place. Check for the victim's natural breathing and consciousness. Take steps to apply respiratory resuscitation if the victim is unconscious and not breathing. Familiarizing ourselves with a few do's and don'ts when working in the plumbing and masonry trade will help maintain a safe environment. Preventing oil spills on the shop floor or work table is crucial for maintaining a safe and healthy environment. Preventing the spread of metal chips on the shop floor is essential as metal chips can pose several hazards as well as cause potential injury from sharp edges. Using a regular forward stroke motion on both sides of the workpiece while using a file is good practice to ensure that even filing happens with consistent results. Tightening the pipe vise handle excessively while cutting a pipe can lead to the pipe breaking or becoming damaged. Keeping your focus on the cutting edge of the chisel while working on a wood block is crucial for precision and safety. Move the blade back and forth on the marked groove at a speed of 40 to 50 strokes per minute for the full length of the blade. Wearing goggles while chipping concrete is essential for protecting your eyes from potential hazards or flying debris that are generated during the chipping process. Using a hammer to strike the vise handle in order to grip the workpiece is a common technique, particularly when extra force is needed to secure the workpiece firmly. Grinding a flat chisel on the side of a grinding wheel, also known as side grinding, is a common technique used to sharpen the cutting edge of the chisel. Preparing the cement mortar, mixing water. As we move on, let us record some safety points while using basic tools and equipments of the trade. Some rulers may have sharp edges. Handle them with care to prevent accidental cuts or injuries. A flat file. Always wear safety glasses to protect your eyes from flying metal chips and dust. Consider wearing gloves to protect your hands from cuts and abrasions, especially when filing rough or sharp materials. A prick punch. Always wear appropriate PPE such as safety glasses or goggles to protect your eyes from flying debris or metal shards. A chisel. Before use, inspect the chisel for any damage or defects that could affect its performance or safety. Drill bit. Always wear safety glasses to protect your eyes from flying debris and dust. Gloves can protect your hands from cuts and abrasions, especially when drilling hard or rough material. A scriber. Check for any damage like loose or cracked tips, burrs on the metal body or dull points. A damaged scriber can break and potentially cause injury. A hammer. Position your hands away from the striking zone to avoid accidental contact with the hammerhead. A tri-square. Inspect the tri-square for any defects, bends, or damage that could affect its accuracy. A bench vise. Exercise caution when operating the bench vise handle to avoid pinching or trapping fingers. Keep hands clear of the vise mechanism and the path of the handle to prevent injuries. Stock and dies. Work on a stable and flat surface to prevent slips or instability while using stocks and dies. Pipe vise. Keep the workpiece in the vise as close as possible to the jaws to prevent vibration when sawing or filing. A pipe wrench. Excessive force when turning the pipe wrench can lead to slippage and potential injury. A basic wrench. While using a basic wrench, applying force gradually allows for better control and reduces the risk of accidents. A jumper. Make sure there are no electrical wires, pipes or other hazards in the area where you are drilling. A block trowel. Be mindful of the sharp edges of the trowel blade to prevent accidental cuts or injuries. At the end of this lesson, we have learned to identify occupational hazards and their potential sources and suggest suitable methods to avoid them. Identify and segregate the waste material in the workshop. Take preventive measures to avoid electrical accidents. Understand and practice precautions to be followed while working in the trade. Record the safety points while using trade tools and equipment. Hope you have a clear understanding of this session. Thank you all and see you in the next video. Hello everyone and welcome to this module on the plumbing trade. In today's video, we will learn about the trade tools and their applications and demonstrate the use of various hand tools including different types of vices. At the end of this lesson, you will be able to measure and mark dimensions and divide the arc circles using a scale, scriber and divider, and demonstrate the use of different vices and various hand tools. Today, we will develop the skills to measure dimensions in materials accurately, whether fully or partially, using a ruler. Utilize a steel tape to measure lengths effectively. Perform marking on materials using a scriber and divide arcs or circles accurately using a divider tool. Measuring with a steel rule and steel tape. When measuring a length, you can place the rule either directly on the surface to be measured or at a right angle to the reference plane, depending on the situation. When measuring with a steel rule, use a contact face whenever possible. This means placing the rule directly against the surface being measured. If the edge of the rule is worn out or damaged, start measuring from the 1 cm line. Holding the rule parallel to the edge of the workpiece is crucial for accurate measurements. Otherwise, it can introduce errors which occur when the position of the observer affects the perception of the measurement. Keeping the steel rule away from cutting tools is essential to prevent scratches and damages and ensure the accuracy of measurements. Using a steel tape measure is an excellent choice for measuring larger lengths accurately. Always use British measurements for measuring trenches and lengthier pipes. Using a scriber. While scribing lines, hold the scriber close to the straight edge. Incline the scriber at an angle of 45 degrees and scribe a line towards you along the edge of the straight edge. Do not apply excessive pressure to avoid the removal of the metal. Scribing lines from the left-hand bottom corner is a practical approach to minimize wastage and ensure efficient use of materials. Here's why this method is preferred over starting from other corners, such as the right-hand bottom corner as shown on the screen. Using a divider. One leg of the divider is placed at the center. Another leg of the divider is used for measuring using the steel rule and then the arcs are drawn. Mark the divided measured parts. Note that the divider legs should be sharpened by using an oil stone frequently. We will now learn to test the functioning of and demonstrate the use of different vices. A bench vise. A bench vise can firmly hold a pipe and help to perform different tasks such as marking, filing, and sawing. This ensures precision and accuracy. A pipe vise. A pipe vise can firmly grip pipes of different sizes, allowing for safely cutting or threading without them moving around. This ensures precision and accuracy. Unlike a bench vise with flat jaws, a pipe vise has curved jaws that conform to the round shape of pipes, preventing damage and providing a secure grip that helps to hold on to larger or heavier pipes without slipping. A chain vise. A chain vise is a specific type of pipe vise that uses a chain mechanism to secure the pipe instead of a screw mechanism. The chain allows for conforming to irregular shapes beyond just round pipes, making it versatile for gripping odd-shaped objects or pipes with damaged sections. A hand vise. The small size of the hand vise makes it ideal to hold and work on small objects like screws. The split pin needs to be straightened, loosening the wing nut to release the split pin. A chain pipe wrench. A chain pipe wrench is designed specifically for gripping and turning pipes, especially in tight spaces or awkward angles. Place the chain wrench head in the pipe bit above 50 mm diameter, holding the pipe using the chain till the teeth grips the pipe, and then tighten the pipe bit until it firmly grips. A leg vise. A leg vise is a heavy-duty clamping tool designed to handle heavier materials. Jobs which require hammering are usually held on a leg vise. The following are the main parts of a leg vise: solid jaw, movable jaw, threaded jaw, spindle, spring, pivot, leg, and clamp. Moving on, we will now learn to use various hand tools efficiently. Use a hacksaw to cut, perform chipping using a chisel, use a die stalk and die to perform external thread cutting, and taps for internal thread cutting. Files. Hold the workpiece in the bench vise, choose the appropriate file, and then file accordingly. A hammer. Place the workpiece on the bench vise and grip. Hold the hammer correctly as shown and then commence the chipping. A center punch. Hold the center punch firmly, place it on the workpiece and then punch as required. A hacksaw. Hold the pipe in the pipe vise and grip firmly. Select the correct pitch of blade and fix it in the forward teeth position. Hold the block frame and cut the pipe. A chisel. Place the workpiece in the bench vise and grip tightly. Hold the chisel in the correct angle and then start chipping. Calipers. Place the calipers on the selected workpiece to find the size of the inside and outside diameter. A pipe wrench. Select the correct number of the pipe wrench according to the diameter of the pipe. Hold the pipe in the pipe vise and ensure it grips properly. Now, adjust the pipe wrench till it grips the pipe firmly and then proceed with the operation. Stalk and dies. A stalk is used to create threads on a metal pipe. Select the correct size of the metric dies. Fix it in the die stalk and lock it. Adjust the dies according to the workpiece. Proceed with the external threading operations. Taps and holders. Taps and holders are cutting tools with teeth designed to remove material and form threads inside pre-drilled holes. Place the tap in the workpiece for the external threading operations. Using the first, second and bottoming taps, with holders that secure the taps and provide leverage for turning them during the threading process. In this lesson, we have learned to measure and mark dimensions and divide the arc circles using a scale, scriber and divider, and demonstrate the use of different vices and various hand tools. Hope you have a clear understanding of this session. Thank you all and see you in the next video. Hello everyone and welcome to this module on the plumbing trade. In today's video, we will learn to create an internal thread or screw hole on an MS flat or a mild steel flat bar using a tap, and also create an outer thread on a pipe using a die set. By the end of this lesson, you will be able to locate holes with a scribing block, drill holes using a pillar or bench drilling machine, determine the tap drill size for internal threading, provide internal threads using hand taps and a tap wrench, cut internal threads using hand taps, select the outer thread providing die set and identify the hand tools, identify the external thread providing pipes and its types, and use the various locking devices. The required tools and material for this are hand tap set 1, pipe vise 1, measuring tape 1, hacksaw frame and blade 1, oil can 1, double-ended spanner 1, ring spanner 1, MS flat as required, oil as required, cotton waste as required, cotter bolts and nuts as required, cotter pins as required, BSP die stock and dies 1, bench vise 1. Let us now learn to cut internal threads using hand taps. Check the material for its size. Apply marking media. Mark the screw hole location on the flat bar as per the drawing dimensions and punch the center of the hole with a center punch. Note that the periphery of the big holes should be punched with a 60-degree prick punch. Fix the job on the machine vise. Also, fix a 4 mm drill in the drill chuck and set the spindle speed for 4 mm drill, as it can be used as a pilot for all the holes. Then fix the 8, 10 and 16 mm drill one by one and drill through the holes as per the job drawing. Remember to use a coolant while drilling. Use a drift to remove the taper shank drill from the drilling machine spindle. Adjust the RPM of the spindle to suit the diameter of the drill. Complete the job and deburr all corners. Also, apply a thin coat of oil and preserve it for evaluation. Caution: use the chuck key for tightening the drill in the drill chuck and do not hammer on the drift to remove it out. Next, let us learn to drill holes of different diameters using a drilling machine. Punch the center of the hole to be drilled using a center punch. Set the job in the machine vise securely by using 2 parallel bars to clear the drill. Fix the drill chuck into the spindle of the drilling machine and fix the 4 mm diameter drill in the drill chuck for the pilot hole. Select the spindle speed by shifting the belt in the appropriate cone pulleys. Drill all the holes first using the 4 mm drill. This will serve as a pilot hole for the 8 mm, 10 mm and 16 mm diameter drills. Follow this by drilling the 8 mm and then the 10 mm hole. Once done, remove the drill and the drill chuck. Ensure that the drill does not penetrate into the vise. Then, fix the drill securely into the drill chuck. Since the large diameter drills are thicker, the dead centers of those drills may not sit in the center punch marks. This can result in the shifting of the hole location. Thick dead centers cannot penetrate into the material easily and will impose severe strain on the drill. These problems can be overcome by drilling pilot holes initially. A word of caution: do not remove chips with bare hands. Always use a brush. Do not try to change the belt while the machine is running. While tapping through holes, determine the tap drill size by using the formula or the table and then drill the hole accordingly. Remember that an undersized hole will lead to breakage of the tap. Chamfer the end of the drilled hole for easy alignment and starting off the tap. Hold the work firmly and horizontally in the vise. The top surface of the job should be slightly above the level of the vise jaws. This will help in using a tri-square without any obstruction while aligning the tap. First, fix the first tap or taper tap in the correct size tap wrench. If the wrench is too small, it will need greater force to turn the tap. Large and heavy wrenches will not work to turn the top as it cuts and may lead to breakage of the tap. Position the tap in the chamfered hole vertically by ensuring that a wrench is in a horizontal plane. Exert steady downward pressure and turn the tap wrench slowly in the clockwise direction to start the thread. Hold the tap wrench close to the center. Remove the wrench from the tap when you are sure of starting the thread without disturbing the setting. Make sure that the tap is vertical by using a tri-square which is at 90 degrees to each other. Make corrections if necessary by exerting more pressure on the opposite side of the tap inclination. Check the tap alignment again. This should be corrected within the first few turns. If done afterwards, there is a chance that the tap may break. Turn the wrench lightly by holding at the ends without exerting any downward pressure after the tap is positioned vertically. The wrench pressure exerted by the hands should be well balanced. Any extra pressure on one side can change the tap alignment and cause the tap to break. Continue cutting the thread. Turning backwards after a quarter turn periodically helps to break the chips. Stop turning backwards when you feel any resistance. Cut the thread until the hole is totally threaded. Remember to use a cutting fluid while cutting the thread to minimize friction and heat. Remove the chips from the work and clean the tap with a brush. Once the job is done, clean up using the intermediate and plug tap as it will not cut any thread if the first tap has entered the hole fully. Here are a couple of things to keep in mind during this exercise. Ensure that the diameter of the hole to be tapped matches the size of the tap. Turn backwards to break the chip after every quarter turn. Select a wrench that suits the size of the tap. For the next part, let us focus our efforts on the tapping of cast iron or CI water lines in domestic water supply. First, turn off the water supply. Mark the position for tapping, which should only be on top of the main. Fix the ratchet brace to the pipe C-clamp. Insert the drill as per the marking and drill the hole by rotating the handle and tightening the top screw. Remove the ratchet drill and cut the internal threads with a taper pipe tap. Fit a ferrule to form the necessary connection and then open the valve inside the ferrule and close the cap. Now, let us learn to use the various locking devices. The first part is the lock nut. Fit the locking nut into the bolt and then fit the nut into the bolt. The second part is the castle nut. Fit the nut into the bolt. Then cut a slot in the cylindrical corner on top of the nut and then insert the cotter pin into the slot of the collar. The last part is the slotted nut. Cut a slot in the upper end of the bolt. Then cut a slot in the cylindrical collar on the nut and insert a split pin through the slot of the nut and bolt. Let us first look at using a ratchet type die stock with one handle. Select a set of dies and a ratchet type die stock. Open the adjustment lever. Coincide the 0 setting mark O die stock and then insert the 4 dies according to the number on the dies and die stock respectively. Ensure that the dies sit in the correct position by making sure that the number on the top edge of the die corresponds with the number of the slot into which it has to be placed. Fix the pipe in a pipe vise and tighten to prevent it from rotating. Ensure that the projection of the pipe is within 150 to 250 mm from the vise. Open the self-centering pipe guide and slide the stock over the end of the pipe. Adjust the pipe guide and set it correctly for sliding. Then fit and lock into position. Apply a cutting lubricant to the part which is to be threaded. Always use lubrication oil while threading GI pipes. Apply a little pressure to the stock and keep the handle at right angle to the pipe axis. When the die is cut into the pipe, stop pushing and continue the rotation by moving the handle up and down. Apply the lubricant to the pipe after the first thread has been cut. Keep rotating the handles in the clockwise direction and check the length of the pipe thread. Ensure that the length of the thread is sufficient to fit halfway into the socket or coupling. If the die stalk and the die stick turn the stalk anti-clockwise to break the chips, then reverse the ratchet knob, ease the handle and turn the stalk anti-clockwise till the stalk and dies come out of the pipe. Clean the thread with a wire brush. Form a thread until the pipe extends about 1 or 2 threads beyond the end of the stalk. Remove the stalk and dies by operating the quick release lever and clean off the thread with a wire brush. Check the formation of the thread with a standard fitting. Repeat the operation if the thread is too tight by adjusting the ties. Now, let us look at using a 2-handle stalk and dies ratchet type. Open the vise and insert the pipe into the pipe vise. Then, close and tighten the pipe vise. Open the self-centering pipe guide and slide the stalk over the end of the pipe. Adjust the pipe guide for correct sliding, then fill and lock in position. Apply a cutting lubricant to the part to be threaded. Then apply heavy pressure to the stalk and keep the 2 handles at right angles to the pipe axis. Rotate the handle clockwise with heavy pressure towards the pipe in a plane right angle to the pipe axis. Apply a lubricant to the pipe and keep rotating the handle clockwise. Check the lengths of the pipe thread and the thread with a socket. Remove the stalk and die and clean off the thread with a wire brush and cloth. In this lesson, we have discussed how to locate holes with a scribing block, drill holes using a pillar or bench drilling machine, determine the tap drill size for internal threading, provide internal threads using hand taps and a tap wrench, cut internal threads using hand taps, select the outer thread providing die set and identify the hand tools, identify the external thread providing pipes and its types, and use the various locking devices. Hope you have a clear understanding of this session. Thank you all and see you in the next video.
Hi, Namaskar and very welcome to all of you. Today I am going to discuss some of the important points to keep in mind during planning of multi-story building or high-rise building. There are proper guidelines and policy